Hello everyone, welcome to the channel Learn with Learner. In this video, I will be starting from the basics of integration. Here, I will introduce you with all the formulas needed in this chapter for integration. In this series of videos, we will cover indefinite integration. And for definite integration, that is chapter number 4 of State Board, I will make another playlist. Okay, so let us start. Now, first of all, this topic is related to the very amazing field of maths, which is called as calculus. So, integration is studied in the field of branch of maths which is called as calculus, and it is a very interesting branch. Now, before integration, in the earlier standard we have studied derivatives, also in 12th standard. So what were we doing in derivative? We were finding the function of x, right? So let me tell you guys that integration is nothing but the inverse of derivative. That means what? Integration is like if derivative is f of x, that is function of x, then integration is g dash of x. That is the g of x. This g of x is called as the, let me write over here, primitive of f of x. Primitive of f of x. Now let me start by telling you what is integration. Now you have understood that integration is nothing but the inverse of derivative. So but even though derivative and integration is related topics, but integration has some things which are way different topics than derivatives. So let me start. So if I further describe you the meaning of integration, it is nothing but area under curves. Integration represents area under curve. Now what does this mean? To explain this, I have drawn a graph here, and on the graph I have plotted a curve, right? So now if I plot this curve, the area under this curve, let me draw it. So this area under the curve is nothing but integration. This represents integration. So in integration we do nothing but something which we call as summation. Now what is summation? Summation is nothing but addition. But what kind of addition? Continuous addition. That means what? In this area, if we make small squares, now addition of these squares continuously is nothing but the summation of dx, right? Summation of or you can say continuous addition of dx. So this is what is integration. Now And yeah, let me tell you, dx means nothing but small change in x. So suppose if we consider this x, so the small change in x and addition of that continuously is called as integration. Now if we see this diagram, this curves never ends from the both sides. It is infinite, right? So even this area is not limited to this, is infinite. So this type of integration is called as indefinite integration, which we'll study in this particular chapter. Now if we range it from something, let's say x is equal to 1 to x is equal to 3, now we have determined its value. So now it is definite integration. But when it is not defined, then it is indefinite integration. So now okay, sorry for the inconvenience. So now we are going to start with the formulas. So to explain you the first formula, I will explain you on the like this. So we all know that derivative of x raised to n is, tell the answer in the comments. You should know this because this was in 11th standard. So the derivative of x raised to n is nx raised to n minus 1, right? So now, as I told you that integration is nothing but the inverse of derivative, then the integration, this is how we represent integration. The integration of nx raised to n minus 1 dx, that is small change in x. These two things are mandatory while writing integration. Will be, guess what? Exactly this, that is x raised to n. Okay, now what does this tell us? This tells us that the integration of x raised to n dx is nothing but x n plus 1 upon n plus 1 plus c. Now what is c? This is nothing but constant. In every answer, after writing the integration, you will have to add this plus c. Okay, it has no value, it is just constant. We have to write it as it is, plus c plus c. Okay, so now again I'll tell you that as I told you that derivative of x raised to n was nx raised to n minus 1. So now this integration will become x raised to n. Here it was n minus 1, but in integration it became n plus 1, and below it was upon n plus 1 plus c. So this gives us our first formula, which was this, that is integration of x raised to n dx is equal to x raised to n plus 1 upon n plus 1 plus c. Now you can also write it as, if x raised to n is not given, but it is given ax plus b raised to n. Are you getting me? Like if this if x what was I saying? I forgot. Yeah, I was saying that if x raised to n is not given, but it is in the format of ax plus b raised to n, then what we'll do is just substitute x raised to n with ax raised to b and write the same formula. No difference. Ax plus b raised to n plus 1. Similarly here n plus 1. Now here comes plus c. Now here comes the twist that here you have to substitute whatever is the coefficient of x and multiply it with the denominator. So that is the only change. Baki everything is same. X raised to n, n plus 1, n plus 1. And here just x raised to n is substituted by ax plus b, and here also raised to n plus 1, n plus 1 plus c. So this is your first formula. Now before going further, let us try to solve these first. So now the question is integration of x raised to 8 dx. Now try to relate this with your formula. So your formula was x raised to n dx, which was equal to x raised to n plus 1, n plus 1 plus c. So here x and x is same, our n is 8. So now substitute the formula in this question. So x raised to n plus 1, n is 8. So x raised to 8 plus 1 upon n plus 1, n is 8. So 8 plus 1 and plus c as it is. So this is your answer. What is 8 plus 1? 9. So your final answer is x raised to 9 upon 9 plus c. So this is your final answer. Sorry for all this mess. So it is as easy as it is. Now if I take the second formula, which was this. Now let me frame a question like this. I'm sorry, I don't know why. Yeah, so let me frame a question like this. 3x plus 2 raised to n. So let me take n as 2. So now how will you solve this? Same. Now your n is 2, a is 3, b is 2. So ax plus b as it is. Here we'll write 3x plus 2 as it is. N plus 1. So 2 plus 1 is 3. So 3. N plus 1. N plus 1 is 3. So upon 3 and plus c as it is. Very easy. You got your answer. That's it. Now let me tell you the second formula. Now guys, let me explain you the second formula. Now what was the derivative of a raised to x? Try to remember. It was a raised to x log a, right? Now if I ask you, what is the integration of a raised to x? Now let me tell you one thing. There is no integration of log a. Okay, integration is not applicable to this. So if I ask you the integration of log a, it is not possible. No one will ask you such kind of question. ठीक है? So if I ask you just the integration of ax, this ax, then what will you do? See, here log A is in multiplication. If it will go this side, it will come in division. So your answer will be AX log A, right? You got your answer. Just you have to add plus C. Done. Very easy. And yes, I'm sorry, I've forgotten to return here dx. So this is your second formula, which is integration of ax a raised to x dx is a raised to x upon log a plus c. Very simple. Now let me teach you the third formula. Now if you are asked d by dx of e raised to x, you all know it remains the same. Derivative of e raised to x is e raised to s as it is. Same goes with its integration. If you are asked with the integration of e raised to x dx, then what will it be? E raised to x only plus c. That's it. This is your third formula. Now all the other formulas I will be giving are trigonometric function formulas. So those are also very easy. So let me write it quickly, and those are very easy to learn. So here we go. Now these are also very simple. Here what we have to do, if in a derivative, if we are asked about derivatives of cos or cosec or whatever, cot, then our answer usually comes with negative sign, right? Here we have to do the exactly opposite thing. If accept sign wala formula, if the integration of something, the integration of these will be minus. So you have to add the negative sign in this side rather than this side. You know what I'm saying? Okay, let me just write all these answers, then you will get what I'm saying. So the integration of sin x is minus cos x. Please remember this, because now see, derivative of sin x was cos x. So what is the integration of cos x? What am I talking? Yes, what is the integration of cos x? Minus sin x, right? So this minus sign comes here. That was what I was saying earlier. So again, cosec is sin x, just sin x. Sec square x. So we know that derivative of tan x is sec square x, right? So this tan x will come here. And please don't forget to write c plus c like me. And also in these questions I haven't written dx, so excuse me for that, and you don't forget it like me. So sec x tan x. So what is the derivative of sec x tan x? Sec square x. So that is your answer, sec square x. I'm sorry. Yes, I'm right. Not sec square x, sec x. Now that goes with cosec. What is the derivative? No. Okay, I told you something wrong. The derivative of sec x tan x is not sec x. This is the derivative of sec x. Sec x tan x is the derivative of sec x. So here I will be asking you what gives the derivative of sec square x tan x. Derivative of tan x is equal to sec square x. What gives the derivative of sec x tan x? Sec x, right? So what gives the derivative of cosec square x? It is minus cot x. So minus cot x plus c is the integration of cosec square x. Again I am saying you have to write the minus sign in this side. Okay, derivative of cot x was minus cosec x. So here I have written that minus sign. Now cot x cosec x. What gives the derivative of cot x cosec x? What? Minus cosec x plus c. We all know that derivative of cosec x is minus cot x cosec x, and minus sign will be here. So these are all your trigonometric functions derivatives. Now these two formulas are not given in the textbook, but I am giving it to you so that your concepts will be easy, and this is given by my tuition sir who teaches very well. So yeah, anyways, so the integration of dx is x plus c. Okay, so what will be the integration of k dx? Now let me just tell you that k I have written here. You can write any alphabet here. It represents nothing but a variable number. Okay, like instead of k, if I give you 3, then what is the, just guess it. Now if integration of dx is x plus 3, what is 3 dx? Simple. Okay, so let me replace you with k. So this is your formula. Okay, now let us take few questions for solving. Let us start solving the solved examples of the textbook. So this is your first question of the solved examples. The question was evaluate. Oh my god, I'm so bad at this. Evaluate. I don't know why I am always confused to pronounce this. I'm not very fluent in pronouncing this. Yeah. So evaluate the following, and this is the first one. So the question is x raised to 3 plus 3 raised to x. Very simple. I've already told you